Hello friends, welcome to Learner's Planet. Friends, this is our third session for the workshop of permutation and combination. And in this session particularly we are going to discuss the concepts and problems based on partitions. I can give you a common example. Suppose I have 30 apples maybe and 30 similar apples. In how many ways can I distribute the 30 apples among A, B and C? Maybe some conditions are there, maybe not, right? So let's discuss these sort of concepts and problems. Okay, and just have your paper and pen with you. Just note down the points that you find new and maybe important also. Okay. Now friends, before you come for this session, you should attend the basic sessions of permutation and combination. In the basic sessions of permutation and combination, we have discussed good number of problems and concepts based on when we have to distribute the distinct objects among the persons, or maybe whatever, maybe 3 different balls into 3 different boxes, 4 different boxes and all that, right? Now what would happen if the objects are identical and the person among whom we are distributing the same are different, right? Suppose 3 identical balls are to be distributed among 4 boxes, or maybe 10 apples to be distributed among 3 persons and all that. Okay, so now we are just going to discuss identical objects and they are distributed among different persons. Okay, so let's see the first example. Now the simplest thing I have 4 balls and 3 boxes. 1, 2, 3. Box 1, 2, 3. Right? Now these 4 balls are identical. And I have to just put up the balls in these 3 boxes. Okay. Now the condition, first condition is, we are discussing this problem with the condition. The condition is no box should be empty. Okay, now just listen to me carefully so you can be you'll be clear with this concept. I have 4 balls, right? These are the 4 balls and all of them are identical, so it doesn't matter which ball is going to which box. The only thing that matters is how many balls are going in 1, 2 and 3, right? So these are the different ways when we have to fill up the boxes with balls, right? Now, see, in the basic session also I have explained you the concept of gaps, right? Here I am having 1, 2, 3 gaps, right? I have to distribute the 4 balls among 3 people, right? So, if out of these 3 gaps, if I select 2 gaps, right? Suppose I select this gap and this gap, automatically I'll be getting 3 partitions, right? One part, second part and third part for first box, second box and third box, right? Or maybe this way, first box, second box and third box, or maybe these 3. So that's first box, second box and third box. That means 2 in the first box, 1 in the second box and 1 in the third box, right? So precisely what I'm doing, I'm just finding out the total number of objects that are, these are 4 in this case, number of gaps are 3, right? I have to distribute the balls among 3 boxes. That means if I choose 2 gaps, right? If I choose 2 gaps, automatically 3 partitions will be there. If I have to distribute the objects among 4 persons, then I need to choose the 3 gaps. Okay, so if I choose 2 gaps, any of these gaps, right, out of 3 available gaps, if I choose 2 gaps, automatically 3 partitions will be there. So there will be 3C2 or 3C1. That's 3 ways will be there to do this. That all the 3 ways I have already shown you. Okay. Since this was a simple example, number of balls were very less, so you can definitely go this way also, like you can make the arrangement of say 1 2 2, I'm sorry, 1 2 1 2 1 1 1 1 2, like this also. But if the number of balls are more, you cannot go this way, right? So you should be conceptually clear. So now let's discuss some more problems based on this gaps and distribution. Now suppose I am having 10 apples to be distributed among 3 persons, A, B and C. A, B and C and 10 apples, right? So 10 apples, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here the condition that is continued, that is none of them should get 0. That means at least one apple each should get, right? So no box is empty, that condition is still continue over here. Okay, no box is empty or no person is empty handed. That means each should get at least one. Now when we are having 10 apples, I have drawn 10 apples over here, you'll be having 9 gaps. Right? So out of 9 gaps, if you select 2 gaps this way, whatever, right? So if you select 2 gaps, automatically 3 partitions will be there. So A is 2, B is 3 and C is 5. Similarly, instead of this, if you select this or maybe this gap, so 1, then 4 and then 5, 6, 5. So this way you can make all the combinations. So precisely what you are doing, you are finding out the number of gaps and one less than that gap you are making the combinations, right? So if 10 apples are there, there will be 9 gaps. If 3 persons are there, you need to make 2 parts. You need to select 2 gaps. Instead of 10 apples, if there are 20 apples, then there will be 19 gaps. Out of 19 gaps, you have to select 2 gaps to make 3 partitions, right? 2 gaps will make 3 partitions. If there are 20 objects, you'll be getting 19 gaps, right? Similarly, suppose you have 30 apples or maybe 30 coins of rupee 1 and you wish to distribute all the 30 coins among A, B, C, D, 4 persons, right? Now if you line up these 30 coins like this, it will take time. So you just have to understand that if there are 30 coins, definitely if you put up like this, there will be 29 gaps, right? 29 gaps, and you need to distribute among 4 persons. That means 3 gaps should be selected. So if you select 3 gaps, automatically 4 partitions will be there, right? So that's 29C. 3 ways will be there if you wish to distribute 30 coins of rupee 1 among these 4 persons, such that none of them will get 0, right? Or everybody of them will be getting at least 1 coin, right? So this is how you can make this problem very simple. Other way of asking this problem is in how many ways, or how many integral solution for this equations, right? Positive integral solutions. Okay, how many positive integral solutions will be there for this equation? The same concept we are using over here. That means positive integral solution means 0 is not at all accepted and negatives are not at all accepted, right? So the same logic you can apply over here. 30 apples are being distributed among 4 persons. So 29 gaps will be there, and out of them 3 gaps you need to select. So 4 partitions you will be getting. First partition for A, then B, then C and then D, right? Similarly, the logic can be extended. So friends, this is a story, this is a concept when we are discussing when 0 is not at all allowed. Zeros and negatives are not at all allowed. See here, 0 is not at all allowed, and in case of integral solutions, negatives and 0, both of them are not allowed. But if the condition varies, maybe 0 is allowed, maybe some negatives are allowed, then definitely the answer and the procedure will vary, right? Now what that variation will be, let's discuss in detail. First of all, you should be clear about this when, and yes, of course, I can give you a formula for that also if you wish to learn for a quick solution. See, if there are A plus B plus C, this number of people, and the sum of all of these is n. So the number of solution, or we can say positive integral solution, will be n minus C r minus 1, right? Here n is this number, total whatever the sum is, and r is this number, r people, right? Suppose A plus B plus C is 30, right? 30 apples are being distributed among 3 people. So n will be 30 and r will be 3. Okay, so that's 29C2. So whenever distribution is there of identical objects, n identical objects among r persons, then this is a formula that you can use when the 0 and negatives are not at all allowed. 0 is not allowed. So direct formula of n minus 1 C r minus 1 can be used. Okay. Now suppose I have A plus B plus C is equal to say 8, right? Now, or you can say 8 apples to be distributed among A, B and C. Previously we were discussing the concept when this 0 is not at all allowed. Now what if 0 is allowed? That is any one of them or two of them can get 0 also, right? And so earlier 1, 2, 3, 4, 5, 6, 7, 8 apples. Suppose I am taking the case of apples only. So if 8 apples are to be distributed among 3 persons with the condition that each of them should get at least 1. So we were doing like this. Number of gaps. So there are 7 gaps. Out of them we have to select 2 gaps. So we'll be getting 3 partitions. Okay, now there will be a change because now 0 is also allowed. So now to make the concept easier, what I do, I make 3 dummy apples. I arrange 3 dummy apples over here. 1, 2 and 3. Right? Now the same concept I'm using. Now this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 gaps will be there. Out of that we have to select 2 gaps. So we'll be getting 3 partitions. Right? Now these 2 gaps will be, maybe this is 1, this is 2 and this is 3. That means A is getting, 1 is getting 2, other is getting this 3 and 3, 6 and the third one is getting 0. Okay? So precisely I'm having 8 good apples and 3 dummy apples. Now these dummy apples can take place anywhere between 8 good apples. 1, 2, 3, 4, 5. Maybe here it's a dummy apple, here it's a dummy apple, this here is a dummy apple. 1, 2, 3, 4, 5, 6, 7, 8. Right? So now if you select, now there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 apples are there inclusive of dummy apples. So out of 11, if you select 11 apples are there, there will be 10 gaps. If you select 2 gaps, maybe suppose this and this, so you'll be getting 3 partitions, right? If you select this and this, what you'll be getting? A is getting 2, B is getting 0 and C is getting 1, 2, 3, 4, 5, 6, right? So 2, 0, 6 is a solution, right? Now this, if you anyways you can rearrange these apples, 8 good and 3 dummy apples. Okay, so suppose you arrange in this manner, 1, 2, 3, 4, 5, then this 7, 1, 2, 3, 4, 5, 6, 7, 8, right? And suppose now you make the selection of 2 and you select 2 gaps, then it will be 0, 3 and 5, right? So precisely 11 apples are there. 11 apples are there, that means there will be 10 gaps. If there are 10 gaps, you need to select 2 gaps. Okay, so 10C2 will be the total number of ways when you have to distribute 8 apples among 3 persons with the condition that any one of them or 2 of them can get the 0 apples, or maybe they do not get any apples at all. Okay, that means precisely 0 is also allowed. Similarly, if you wish to find out the solution of an equation, maybe A plus B plus C is equal to 8, right? Here non-negative integral solution I am talking about. In the previous case we were talking about positive integral solution when 0 was not at all allowed. Now non-negative integral solution, that means 0 is allowed but negative numbers are not at all allowed. That means the same thing, the same concept will work over here. Since 0 is also allowed, so 8 apples plus 3 dummy apples minus 1 gap. Out of that we need to select, out of this 3 minus 1, we need to make 2 partitions, we need to select 2 partitions. Okay, so total 8 plus 3, 11 objects, 11 objects minus 1, there are 10 gaps. Out of them you have to select 2 gaps. Okay, so precisely that is N plus this is R minus 1 C R minus 1. This is the direct formula that you can learn also. The previous case N minus 1 C R minus 1 for positive integral solution and this is for non-negative integral solution. Okay, so you are getting the difference between the two. Positive means 0 is not at all allowed, non-negative means 0 is allowed. Okay, so direct formula, if you learn, that will also be very good, and your concept should definitely be clear, because if any twist is there, direct formula cannot be applied. Okay, let's take one or two more examples. Now, an alternative approach can also be seen in this case when a plus b plus c is suppose maybe 8, right? Now 1 2 3 4 5 6 7 8. Okay, 8 apples are there, and we have to make 3 partitions, and or alternatively I can say we are looking for non-negative integral solution. That means even 0 is included, right? Now what I'm doing, I need to select 2 gaps obviously out of these available gaps. So what I do, I introduce 2 gaps, right? Because I wish to have 0 also as solution. Now this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letter word, and a 10 letter word can be arranged in 10 factorial ways. Now all these O's, or we can say apples, are identical. So I'll divide by 8 factorial, and both the gaps are also identical. So I will divide it by 2 factorial. So this is precisely 10C2, right? So this way also you can go. So that is nothing but 8 plus 3 minus 1 C3 minus 1, or n plus r minus 1 C r minus 1. Okay. Similarly, if you want a plus b plus c plus d, maybe 4 this persons are there, and these are 10 apples to be distributed. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In that case, you need 3 partitions or 3 gaps. I introduce 3 gaps, and all the gaps are identical. All the apples are identical, obviously. So this is 10 plus 3, 13. So 13 factorial ways, all the apples are identical, so divide by 10 factorial, all the gaps are identical, so divide by 3 factorial. So this is actually 13C3, or we can say 10 plus 4 minus 1 C4 minus 1. Okay? Basically, you can use these gaps anywhere. Okay, so that's why with the rearrangement of this zeros, or we can say apples, and this gaps, we are getting those many words, right? So in this way also you can understand this concept. Finally, for non-negative integral solution, this is the formula. Okay. One more important thing over here. See, if in the previous case there were 3 people, that means ABC, and we were distributing 8 fruits or 8 apples among them. Now suppose there are more persons, 4 persons, then you need to introduce 4 dummy apples, because if in case 4 dummy apples are there, and if anybody is getting all the 4 dummy apples, then only he'll be getting the 0 as the solution. That means 0 apples, right? So those many people are there, those many dummy apples you need to introduce. So precisely n plus r minus 1 C r minus 1 formula, where r is number of persons. Okay, be clear about it. Now the next condition, suppose I have suppose a plus b plus c plus d, maybe it is 30, right? And we have to find out the non-negative integral solution, or we can say or we have to distribute 30 apples with the condition that each should get at least 2. Each should get at least 2. Now what will we do? We will distribute 8 apples before anything else, right? 2 apples to A, then B, then C and D, right? So 8 apples are already gone. Now we are left with just 22 apples, right? Now if anybody of them or two of them or three of them, even if they are getting 0 apples, then also no problem, because they already have 2 apples, because we have already given them the 2 apples, right? So this problem is converted to this problem, right? Because we have already distributed 2 apples to each of them. Now we have just 22 apples to be distributed. Now 0 is also allowed. Okay, so that's 22 plus 4 minus 1 C 4 minus 1. So 22 plus 4 26 minus 1 25 C 3 ways will be there to do this. Okay, now if the condition changes, maybe A should get at least 2, B should get at least 3, C should get at least 4, and D, maybe D cannot, for D maybe 0 is also allowed, right? So what will we do? What will be doing? 4 and 3 7 and 2 9 apples will distribute. After that, A plus B plus C plus D is 21. Now find out the non-negative integral solution of this equation. So that is 21 plus 4 minus 1 C 4 minus 1, right? Now even A, B and C they are getting nothing, even when they are getting 0, that means then also they are having 2, 3 and 4 apples respectively. And we haven't given anything to D. So for D, if he is getting 0, doesn't matter, because there is no condition for D. Okay, so this is how you can approach the problem. So a simple concept is there. I have explained the concept as well as, and the direct formula also I have given you. So if at all you learn the formula, it will be very easy for you to solve the problems based on this. Okay. Now here see, Manoj went to the market to buy fruits. It is known that he bought 20 fruits in all, comprising apples, bananas and chikus. In how many ways could he have bought the fruits, given that he bought at least 3 of each type? Okay, a apple plus banana plus chiku, in all there are 20, right? And he is buying 3 of each type. That means 3 apples, 3 banana, 3 chiku. We just select, and now we are left with A plus B plus C as 11, right? 20 minus 9, 3A, 3B and 3C, right? Now we have to find out the non-negative integral solution of this equation. So 11 plus 3 minus 1, C 3 minus 1. So that's 12C2. Okay, as simple as that. I hope you are getting it. I'm sorry, it is 11 plus 3, 14 minus 1, 13C2. Okay. Now suppose I have to find out the number of integral solutions if maybe A plus B plus C plus D plus E is say 20, and over here A plus B is equal to 15. That is the condition, and suppose I have to find out non-negative integral solution. That means 0 is also allowed. Now A plus B is 15, that means C plus D plus E must be 5, right? So how many non-negative integral solutions will be there? 5 plus 3 minus 1, C 3 minus 1. So that is 7C2, right? So that's 7 into 6, 42 by 2, 21, right? And how many integral solutions, non-negative integral solution for A plus B is 15. So A plus B is 15 is 15 plus 2 minus 1, C2 minus 1. So that's 16 C1, or we can say 16. So in all 21 into 16 solutions will be there. So that's 336 solutions will be there when A plus B will be adding as 15 and C plus D plus E will be 5. Right, and we have found out non-negative integral solution of this equation. Okay. So till now we have discussed the cases when there is lower limit fixed but no upper limit is fixed. Now we discuss the cases when upper limit is also fixed. Upper limit is fixed. Right, in the previous case we discussed that at each should get at least 1, at least 2, or whatever, at least condition was there. In this case, suppose at most is there. I take one example. Suppose there are 3 persons, they are playing maybe Ludo, right? And all of them are say suppose throwing the dice. All of them are suppose throwing the dice, and we have to find out, okay, the sum of the dice should be 15. Sum of the dice should be 15, right? Sum of the numbers that is appearing on the 3 dice of the 3% should be 15. Okay, now I suppose A for the first person, B should be for the second person, and C should be for the third person, right? So A plus B plus C should be 15. Now you must be knowing, directly it is not written that there is an upper limit, but you know that on a dice only 6 numbers are there, right? The minimum value is, the minimum number of dots is 1 and the maximum is 6, right? So if we take all the cases, what will happen? 0, 0, 15 will also be there. 1, 1, 13 will also be there. 2, 1, 12 will also be there. But none of the die can get 12, 15 and 13, right? So that means there is a hidden upper limit. Now what is that upper limit? That minimum 1 should be there and maximum 6 should be there, because it is dice, it doesn't show 0, it doesn't show more than 6 values, right? So minimum value should be 1 and maximum value should be 6. Okay, so just try to understand this concept. So friends, to understand this concept, we'll be taking a reverse approach. See, A plus B plus C is 15 over here. The maximum number that can appear on a dice is 6. So at max, A plus B plus C is 18 at max, right? Now, what we want, A plus B plus C is 15 and the maximum A plus B plus C is 18, right? So what we do, we find out the condition when all of them are together losing 3. What 3 is? Difference of 18 and 15. Now I just elaborate it, listen to me carefully. Suppose A is losing 0, B is losing 1 and C is losing 1. That means what is happening? The number that is appearing on A's dice is 6. The number that is appearing on B's dice is, I'm sorry, this is total loss is 3. So this is 1, then this must be 2. Right? So A is losing 0, B is losing 1, C is losing 2. That means the number that is appearing on A's dice is 6, the number that is appearing on B's dice is 5, the number that is appearing on C's dice is 4. So 6 plus 5 plus 4 is 15 automatically. Right? So what we are taking a reverse approach. We are finding out the number of ways in which A plus B plus C, A, B and C together they are losing 3. So 0, 1, 2, maybe 1, 1, 1, in that case 5, 5, 5 will be getting, or maybe 1, 2, 0, that means this is 5, 4, 6, right? So that will be rather easier for us because the direct solution is really lengthy and time consuming as well. Even you need a lot of space also. So that's why we are taking the reverse approach. Okay, and that's pretty easy. You will be able to understand it very quickly. You want A plus B plus C as 15, but the maximum A plus B plus C is 18. So that the loss of 3. Okay, how can A, B and C take this loss, right? A is losing 0, B is taking 1 and C is taking 2, or maybe all of them are taking this loss as 1, 1, 1. Okay, I take more examples for that. Should be clear. Now, this problem, in how many ways a person can score a total of 130 marks in an exam consisting of 3 sections of 50 marks each. That means A plus B plus C is 150. And we have to find out the non-negative integral solution of this equation. But once again, the upper limit is fixed. See, the solution here possible is maybe 148, 1 and 1. Right, but the upper limit is what? The section is having 50 marks at max, right? So none of A, B, C can exceed 50. So that's the upper limit, right? So what we can do, again we can take a reverse approach. So what I'll do, in all it is possible, I'm sorry, here we want 130. Maximum marks which are possible, that is A plus B plus C is 50. That's max possible. Right? So precisely, if he is getting 130 marks, that means in all it is losing, this person is losing 20 marks. Right? So this 20 marks, the loss can be distributed among the subjects A, B and C, right? So A plus B plus C is 30. I'm sorry, 20, right? Suppose now he's, for an example, he's losing 1 mark in A, 2 mark in B and maybe 18 mark, 17 mark in C. That means in A subject, the section A, he is getting 49 marks, and it's getting 48 marks, and here he is getting 33 marks, right? So that's appropriate. Okay, so what we do, we find out the non-negative integral solution of A plus B plus C is equal to 20, right? So that is 20 plus 3 minus 1 C 3 minus 1, as we have discussed earlier, N plus R minus 1 C R minus 1. So that is 23 minus 1, 22 C2. So that is 22 into 21 by 2. So that's 231 ways are there when the person will be getting the total as 130, keeping the upper limit of any section as 50 marks, right? That means none of A, B, C will be crossing 50. Okay, so in all there are 231 ways. So this problem becomes simpler if we take the reverse approach. Okay, let's take some more examples. Now suppose we have to find out the non-negative integral solution for x plus y plus z is equal to 12, and x, y and z, all of them are less than equal to 5. That means none of the value of none of x, y and z is exceeding 5, right? So now this is the condition. That means at max x plus y plus z will be 15 at max. Okay, now what is the loss? That is 3. That means this loss of 3 we distribute among these 3, and we find out the non-negative integral solution for this, right? Now suppose once again, for example, if x, y and z they are making a loss 1, 1, 1 each. That means x is actually getting 4 marks, y is also getting 4 and z is also getting 4, maybe marks or maybe whatever the object is, right? And suppose it is 2, 1 and 0. In that case, x is getting 2 marks he is losing, that means he is getting 3. He is losing 1 marks, that means he is getting 4, and he is losing 0 marks, that means he is getting this 5. Okay, so 3 plus 4 plus 5, the sum is 12. So again we are taking a reverse approach. So I hope you are clear with this reverse approach as well. So how many ways will be there? That's 3 plus 3 n plus r minus 1 c r minus 1, right? So that is 5 c2 or 10 ways are there when sum of x plus y plus z is 12 and none of them is greater than 5. Okay, one of they may be equal to 5 but none of them will be greater than 5, right? I hope you are clear with this concept. Friends, in this session we'll be discussing this much only. In the next session of distribution and partition, we'll be taking some more concepts, some more problems, more tedious problems even. So get ready for the next one, and before you come to the next one, just be very clear, be very thorough with this particular session. Okay, so bye bye.